Here are some more problems from section 3.3. In problem number 15, we're asked to find dy dx when y is equal to the quantity x cubed plus x plus 1 times the quantity x to the fourth plus x squared plus 1. Now we could expand this, or we can use the product rule. In this case, it would make more sense to use the product rule. So let's go ahead and use the product rule for the product x cubed plus 1 plus x plus 1 times x to the fourth plus x squared plus 1. The derivative with respect to x of y is dy dx. If we're using the product rule, we'll first by saying first times the derivative of the second plus the second times the derivative of the first. And so we end up getting x cubed plus x plus 1 times the derivative of this, and we'll take this term by term, 4x cubed plus 2x, and then we'll multiply or add that to the x to the fourth plus x squared plus 1 times the derivative of this, which is going to be 3x squared plus 1. Alright, so there we have it. There is our derivative, and what we need to do is confirm that graphically. Now the way we're going to do that is we're going to go into calculator mode, and we are going to put in the original function x cubed plus x plus 1 quantity times x to the fourth plus x squared plus 1 n quantity, and I'll do a zoom normal for that. Let me do a zoom fit. Not zoom fit. Yeah, a zoom fit. Let's see if we can get a better window. In zoom fit, of course, it looks for all the essential elements of the graph, and then tries to find a curve that looks best to that. We're going 10 by 10. Oh my, those are very, very large numbers. Okay, so maybe zoom standard would be better. And what do we see? We see that the function is always increasing. We see that it doesn't have any horizontal tangents. So we expect the derivative function, at least in this small area, I don't know, let's make x or y just a little bit bigger and see if something interesting. How about from negative 100 to positive 100, and then let's count by tens. Let's just see if anything interesting happens. Nope, it's pretty much as we said. It's always increasing, and let's go ahead and let's also graph the derivative function, and that's going to be x cubed plus x plus 1 times quantity 4x cubed plus 2x plus x to the fourth plus x squared plus 1 times the quantity 3x squared plus 1. Alright, and let's go ahead and graph those two simultaneously. There's the original graph, and again what I expect to see is a function that's always positive. Okay, and you can see it's steep here, and that gives me some large positive numbers up there. It's the original graph was steep here, and you can see the derivative graph also has some positive numbers. And if I were to zoom back to my standard screen, you're going to see that the derivative graph never makes it to 0. There's the derivative graph, never makes it to 0. So there's problem 15, in which we do the derivative and we support it graphically. Okay, let's take a look at number 17. Number 17. In number 17, we are told that y is equal to 2x plus 5 over 3x minus 2. And again, we're asked to find dy dx. So what we'll do is we'll take the derivative with respect to x of y, and we'll take the derivative with respect to x of 2x plus 5 over 3x minus 2. And in here we're going to use the quotient rule. So the derivative of y with respect to x is dy dx. Derivative of this expression is going to be bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's see if we can clean that up a little bit. How about 6x minus 4 minus 6x plus 15 all over 3x minus 2 quantity squared. Let's distribute that negative sign through, and we're going to see these 6x's cancel out, giving me a negative 4 and a negative 15, a negative 19 on top, and 3x minus 2 squared on the bottom. Let's confirm this graphically. Again, we'll start by putting in the original function, which is, again, 2x plus 5 quantity divided by 3x minus 2 quantity. Let's graph that with the standard window. Okay, so we see a function that's decreasing here, so that's going to give us a negative derivative. We see a function that's decreasing here, that's negative derivative. We see that here and here we are very, very steep, so expect very, very large negative numbers when we put in, we graph the derivative function. So let's go ahead and put in negative 19. Oops. Negative 19 divided by quantity 3x minus 2 quantity squared. Okay, and we can tell, by the way, by looking at this, the bottom, the denominator is always positive, so this function is always going to be negative. So there's our original function again. And there's our derivative function, always negative, getting very large and negative as we get next to that vertical asymptote. Great. And then let's take a look at number 19. Number 19 is y is equal to x minus 1 times x squared plus x plus 1 all over x cubed. Let's take the derivative of this with respect to x, the derivative of this with respect to x, and let's see what we get. We get dy dx over here. Now this is a quotient, but in the top we're going to have a product rule going on as well. So let's start with the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all over the bottom squared. So let's see if we can do some cleanup here. X cubed. So what is the derivative of this? Well, it's the product rule. So we have to use first times the derivative of the second plus the second times the derivative of the first. And that clears off the derivative of that. Minus x minus 1 times x squared plus 1 times the derivative of x cubed, and that is 3x squared. And again, all of this is over x to the 6th. Now, let's see if we can clean this up a little bit more. X cubed times, this is going to be x squared, x minus plus x minus 2x minus 1 plus x squared plus x plus 1 minus, and then we have to expand all this. Let's do these two terms first, and we get x cubed plus x squared plus x, and then we'll do the negative 1 minus x squared minus x minus 1, and that whole thing is multiplied by 3x squared, and that's all over x to the 6th. Okay, let's see what we can do here. X cubed times, let's collect all the x squared terms. X squared, 3x squared from here and here. We've got a plus x, we got a plus, we have a plus x, a minus 2x, and another plus x. So I've got two x's and two negative x's. Those cancel out. And I got a negative 1 and a positive 1 that cancel out. So I'm left with just that on top. Minus. And let's see what I have here. I got an x squared and x squared, negative x squared cancel. I got an x and a negative x that cancel. So I'm left with minus x cubed minus 1 times 3x squared. And that's all over x to the 6th. So this is 3x to the 5th minus 3x to the 5th minus x squared, 3x squared, all over x to the 6th, which is equal to, let's distribute this negative sign through, 3x squared over x to the 6th, or 3 over x to the 4th. Great. And now let's see if we can confirm that graphically. Putting in my original equation, x minus 1 times x squared plus x plus 1, and then divided by that by the quantity x cubed, and then I'll put the derivative function 3 over x to the 4th in the bottom. And let's go ahead and let's graph that using the standard window. So there's our original function. Looks like it's got an asymptote at 0, and then we see the original function was positive everywhere, and then our derivative function was also positive. We saw that where the asymptote is, we went the derivative function with large and positive as well. So that looks like a good confirmation. Number 21, y is equal to x squared over 1 minus x cubed. Let's see, if I take the derivative with respect to x of y and the derivative with respect to x of x squared over 1 minus x cubed, it looks like I'm going to use a quotient rule that dy dx is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom, and that's all over the bottom squared. The derivative of x squared is 2x. Derivative of negative x cubed is negative 3x squared. And this is all over 1 minus x cubed squared. Let's distribute this through. 2x minus 2x to the fourth minus, this and that cancel to make a plus, and we end up with 3x to the fourth all over 1 minus x cubed squared. So collecting our common terms, I got a negative x to the fourth, I got a positive negative 2x to the fourth, a positive 3x to the fourth, x to the fourth plus 2x all over 1 minus x cubed squared. Alright, let's confirm this graphically. So let's go back to my y equals menu. Let's put in x squared divided by the quantity 1 minus x cubed. Let's go ahead and look at that graph. Okay, looks like it dips up a little bit, comes down and comes back up. So it looks like I have two horizontal asymptotes there and there, and I expect that the derivative function is going to be 0 there. Again, we have increasing everywhere function. No, sorry, it's increasing almost everywhere. It's decreasing in this little area here, but otherwise it's always increasing. So I'm looking like something is going to be positive, hit 0, be negative a little bit, hit 0 again, and then shoot up, and then it's positive all the way through there. Let's go ahead and graph the derivative function and see if it matches our expectations. X to the fourth plus 2x, and we're dividing this all by 1 minus x cubed quantity squared. Okay, and you could barely kind of see that little dip there. Let's go ahead and zoom in. There's my original function. Here's my derivative function. It dips down, it dips back up. Okay. And where is it dipping down? Where we have a horizontal asymptote there. There's a 0 for that derivative. The original function has a horizontal asymptote. It looks like it's 0, and you can see the derivative function also has a 0 there. Alright, and that's problem number 21.